Welcome to Semester B. My name is Henry Provencio. I'm the Innovations and Efficiencies Coordinator for the Forest Restoration Initiative, or FORFRI. So FORFRI is an initiative with about 32 different stakeholders with the goal to restore 2.4 million acres of ponderosa pine forests across northern Arizona's ponderosa pine forest. That would be the Apache sitgreaves, the Coconino, the Tonto, and the Kaibab National Forests. Our field trip today was to talk about some of the management considerations for projects that we do, particularly for wildlife, and what are the different components that we look at when we come out to the field. What are the things that drive how dense maybe a stand might be, or what prescriptions we might apply to a particular area.
Hi, I'm Dick Fleshman. I'm the Operations Coordinator for the Forest Restoration Initiative. Today's field trip's going to look at 3 different stops. They're all restoration treatments that we have undertaken or are just about to undertake on the Coconino National Forest, which is one of the 4 forests in the Forest Restoration Initiative. The first project is the Mountain Air project, and that was a fuels reduction project that was completed, the National Environmental Policy Act document, which we need to do before any treatments could occur. We need to be able to disclose the effects to the human environment, and once we get that, then we can start implementing projects to meet our restoration goals. This first stop, we're going to be taking a look at understory vegetation. We're going to be looking at different treatments and their effects related to different wildlife species, as well as just to ecological function. Actually, the second stop, we're going to be comparing 2 different project areas. On the east side of the road is an untreated area. It's the Clark Task Order, which is in the Elk Park environmental document. That's another fuels reduction project. We're going to be looking at understory response and differences between untreated areas across the FORFRI landscape, as well as treated areas, and also looking at some of our historic evidences and how that influences how we design our treatments. Talk a little bit about soils there as well. The other side of the road, the west side, is actually the Howard timber sale. We're going to be looking at how we actually log that and different effects of treatment there, and some issues related to slash removal and treatment and smoke, and also just different sizes of trees and how they are related to wildlife habitat there as well. Our last stop is actually in a Mexican Spotted Owl Protected Activity Center on the Clark project, which is again part of the FORFRI project area. We're going to be looking at different habitat features within that site, and talk a little bit about uneven age management, even age management within that site, and how that affects species across the entire area.
Hello, my name is Bill Noble. I'm currently retired. That's something you'll all be thinking much more about in another 20 or 30 years. But before that, I was the biologist for the Forest Restoration Initiative. The FORFRI is the largest restoration project in the history of the Forest Service. It's the largest NEPA document done on a site-specific basis in the history of the Forest Service. So coming into this big project, it's going to be the project with the biggest impact on wildlife species because of simply the scale of this and this exciting opportunity to move in a restoration direction, which is going to benefit wildlife tremendously. So landscape scales for connectivity included working with Arizona Game and Fish, where they had data, some of it from telemetry, some of it from incidental observation of black bear movement. So we created corridors around the city of Flagstaff for black bears. We connected closed canopy species by leaving higher canopy cover in drainages. We looked at about 1 million acres, and we have one corridor that transcends almost the whole length of the project. most projects are typically about 30,000 acres, maybe 20,000, maybe 50,000. So working at 1,000,000 acres allowed us to do things you can't commonly do with wildlife and take into consideration things that get left off the table, like what's happening outside of your boundary area. Well, in this case, many of the populations are totally within the boundary area. So this large-scale look let us do a much more realistic assessment of wildlife and do things that would be outside the scale of other projects within our boundaries to benefit populations. So it was a huge opportunity. And the nice thing with restoration, if you have a healthy forest that is going to be resilient over time, then you have good wildlife habitat. And vice versa. If I have ideas on how to create good habitat, it worked real close with silviculture's views on sustainability as well. And then that worked for fire. The three main things that drive projects are silviculture, fire, and wildlife. So we all were basically looking for the same goals in this, just coming at it from different directions, which created opportunities most projects don't get. So 4Fry is landscape scale, it's moving towards resiliency, and it really afforded great team dynamics. Something I hope you all get to enjoy in your career.
Okay, we're in the mountain air fuels reduction project. It was primarily intended as a project to reduce the threat of wildfire entering the community's mountain air, obviously, in Flagstaff. This was one of our first attempts at restoration, where we would do a clumpy, groupy type prescription, and we'll be able to point out some of those characteristics right behind us. The project was initially implemented, cut in about 2011. And since 2011, I believe Dick was saying it was 2015, we had a prescribed fire, at least the initial prescribed fire, come through here. We talk about some of the characteristics that we have out here. So as you look out into the distance here in the back, you can see some older trees, and we know that because of the yellow bark, the larger structure size in those trees. And then in the foreground, some of these black trees, they're not much different in diameter, however, they're much younger, and we can tell that through the bark characters, the color of the bark, and the characters of the tree. Typically with an older tree, you're going to see large branches extending out, a flatter top. It's pretty easy to tell once you get down here, maybe some big drooping branches, where some of the younger trees, not quite the same characteristics, a lot smaller branch size, a little more conical in shape, and obviously the biggest characteristic is the black bark. For restoration, we try to manage for structure, pattern, and composition. So structure is what are the size and age classes that are making up the stand. Composition is what are the species making up the forest structure. So do you have different species, or are they all the same species? So if you look out here, you know, how many species of trees do you see? There's really only one. And then the biggest part, I think, of composition is in the understory. And so if you look out, you can see that grass is the biggest component right now, but if we were to come out here, say in about a month or so, you start to see some of the forbs coming out that are much more important for wildlife. Bill can talk about the trophic levels and maybe the different forms of wildlife that we manage for. On each and every acre, we have to give consideration to wildlife, as well as archaeology, soils, a whole number of things. But the primary driving factor for this project was fire. And so I'm going to turn it over to Dick, and he can talk about some of the things we've missed here, like what's happening now in the understory, and maybe pointing out a few of the characteristics of this stand that make it unique, I guess. And one real important thing we wanted to talk about was these stumps. And Throughout northern Arizona, we're pretty fortunate because these stumps tend to last a long time because it is so dry and because we've interrupted the fire regime. Most of these stumps were cut in the 19-teens primarily, and they were cut by hand with a bow saw, and that's why they're so tall. But the beauty of these is we can look around this landscape and we can count how many trees we probably had pre-European settlement. And you can also count some of these old trees, these yellow trees, that were pretty small in those days, and was probably why they didn't get cut. If you figure we go back 100 plus years, well, those trees were probably pretty small and they were less desirable. So that gives us a real idea of what the composition in terms of number of trees and pattern throughout the landscape. So Dick, you want to talk about a few things here?
Okay. Just want to piggyback on some things Henry mentioned. And he said when we look at that large stump and look around, is what we call that our historic evidences, and then we can actually tell the number of trees per acre that occur on a landscape across different areas across the Fry landscape. So on average, we know from a lot of science, and a lot of it coming out of Ecological Restoration Institute and Northern Arizona University School of Forestry, number of trees per acre on average across a landscape, about 25 to 125 trees per acre is what we would see. And that was made up primarily, 60 to 65% of that should have been big old trees in an open grown condition. But open grown in clumps and groups. Henry mentioned clumpy groupy. So our pattern, and again, looking at our historic evidence, is we could tell what that structural pattern is. But by pattern we mean how are they spatially distributed across the landscape. So we tried to mimic that with these groups that you can see. We're in a small group. We define a group by if we can actually have interconnecting canopies. That's real important to have interconnecting canopies, especially for some of our for tassel-eared squirrel is one species in particular. So that's real important is our pattern. And formative features that happened across this landscape that kept it at that 25 to 125 trees per acre was very frequent fire. Our landscape, on average, every 3 to 15 years there was a fire. A lot of it was lightning. We have a lot of lightning around here, but a lot of it was anthropogenic too. Native people starting fires to actually get the species they wanted because the response from the fire, and actually move animals around. So what happened was our fire actually came in very frequently. We have 3 main fire adaptations in ponderosa pine, actually 4. I think about it. So the needles drop every 3 years. 3-year-old needles in the fall, they'll fall off. They promote fire spread. The bark is relatively thick and actually can withstand low temperature fire on it. The other thing is on the terminal bud, they have a protective sheath. And then another thing is the bark actually sloughs off when they get heat to help protect the cambium as well. So what that did, this was actually burnt in 2015. This black mark up to just above my head is where this scorch was. What that would do, that would actually raise the canopy. So when we actually did get a fire in, we wouldn't get that connection from surface fire into the canopy and start a crown fire. So that actually, our stands, we can look at some trees that have much clearer lower limbs. It's because it had frequent fire in it. Mentioned frequent fire in here and what it would do. One of the things we do, another thing when we actually prescribe burns, one of the things we're trying to do is actually raise the crown base height. That's what we call a crown base height, is height to the first live limb. So where if there's actually a surface fire, can it actually connect with that? Frequent fire actually cleared the bottom part of trees around here. You can see that thing's clear up to almost 30 feet. And that's just because we had frequent fire in here. So when we prescribe burn, we're trying to do the same thing over time, is actually get that clear lower part of the tree. So when a fire does come through here, we don't have interception with the canopy and cause a crown fire. Okay, some of the issues we have when we implement that we have to be thinking of and try and mitigate is introduction of non-native species. This is mullein plant that's non-native that will come into our sites. If we're not careful, we can try and mitigate that as best as possible, but this has a real impressive longevity to its seed. It can actually stay in the seed bank over 100 years, so it's really hard to mitigate that. But some of the things we do for that is with our contracts, we require any equipment that comes on site, it needs to be cleaned. And by clean, that means pressure wash, so it needs to come on site clean. So that's some of the mitigations we do. Another thing is, remember we talked a little bit about number of trees per acre is desired is 25 to 125 trees per acre, is the amount of regeneration we get after this treatment. These are all trees less than 5 years old that have come in since this treatment. So this is one of our challenges. This is normally kept to these numbers by real frequent fire, again 3 to 15 years. This was burnt 5 years ago. It's ready to burn, but these trees, when they get this height, they're hard to kill. So this will be a future management action that we'll have to take. We'll have to come in here and physically cut these down, either through hand thinning or some kind of mechanized piece of equipment to get these thinned out. Ideally, you get enough grass, carries the fire, we burn often enough, it keeps these down. But this is going to be a huge challenge to us at the basal areas we're leaving in our desired conditions.
So a common idea for wildlife is save the forest and you save wildlife. And across a lot of the western states, that means that cutting trees is viewed as negative for wildlife. And it's very different here in northern Arizona. Dick was saying the density of trees historically, which historically is generally before 1870, that the number of trees would range from 25 to 125 trees per acre. Some areas were over 1,000 trees. There's like 50 times the density in some of the research plots that Pete Fillet has done. And so when you change the forest structure so dramatically from groups of trees with basically a sinuous interconnected meadow winding in the openings between the groups, and then you go to a continuous closed canopy forest, you're affecting the native species here. So by pushing things back to where they were historically, we're cutting more trees than we're leaving, and by doing that we're benefiting the native wildlife species that evolved on this more open landscape. It was open at the from the drone perspective, looking down at it, but at the same time the trees were not evenly spaced like a plantation. They were in groups or clumps, and the groups of trees would provide interior habitat, the closed canopy habitat, and then the openings provided the open habitat. So you can get a mix of species, and you might be able to hear there are juncos and bluebirds here, flickers are common, and you have much fewer of those in the closed canopy. So part of keeping this in its historic condition is repeated burning. About every square foot would burn somewhere between every 2 and 20 years historically, and much of northern Arizona hasn't burned since the late 1800s. So that allows this regen, like that's all around us here, although this is new regen, not from historic conditions, but this is since the 2015 prescribed fire or the 2018 cut. But one issue with the burning is you lose snags. They're vulnerable to fire. And a common phrase is you lose some, but you create some. But not all snags are created equal. So you create short-term young snags, snags based on young trees, and they don't get the same kind of wildlife use like the snag behind me. This is a classic snag. It's recent, it still has the bark, so a whole range, over 100 different species of wildlife use a structure like this. Some birds nest in the plates of bark that flake out. Bats can roost in these if there's a right kind of crack and structure where they could get into the tree. Some of Dr. Chambers' work has found that maternity roosts of bats commonly have over 100 females, and they commonly have one pup each. And she's counted over 600, I believe even 900 bats coming out of a single snag. Presumably each one has a pup inside, so when people are cutting firewood, don't cut these things. If it's a maternity roost, you could be killing hundreds of animals. So we don't have many of these because fire takes them out, and there's this dearth of the big old trees that used to dominate the landscape. So we did mention dead top trees. I called those the living dead or zombie trees. They're resistant to fire because they have the living bark in the lower portion, but the upper portion provides snag habitat, and cavity nesters will drill into those just like they would a normal snag. And then another thing we have in northern Arizona, because of the Mogollon Rim, we have the second highest number of lightning strikes in the nation, second after Florida. And so a lot of the big old trees have lightning scars on them. And if you are walking through the forest and look at those, it's not unusual to find cavities drilled into the lightning scar. So again, you have a living tree that's resistant to fire, but because of the conditions on that individual tree, snag-related species can use it as well. So fire, when you're modeling, and with the Forest Service we have guidelines, how many logs, how many snags to leave. You may be missing your target, but one way to address that is leave dead top trees. You don't have to leave all of them. There's a lot out here. There are a lot of lightning strikes, but you can have a preference for leaving those. So in the long run, you're providing for a range of species. And then understory was mentioned. Somewhere between 95 to 98% of the trees in the forest are ponderosa pine, but the vegetative diversity is in the understory. And you probably heard about connectivity and probably heard about pollinators. When we're in a dense forest and you lose most of the grass and forbs underneath and you have a carpet of pine needles, think of connectivity at the scale of arthropods, like butterflies or bees. It doesn't take a lot of pine needles to disrupt connectivity at the arthropod scale. And frequently connectivity is looked at landscape scales for large mammals, but as you've probably heard, we're losing pollinators, we're losing native bee species, and one way to account for that is leaving the interconnected openings that provide the understory diversity in the middle of a forest where you have clumps of trees providing the interior habitat for closed canopy species. So getting back to historic conditions is an example of where you can have it all. So there's been a drastic decline in native bee species and in pollinators in general. One of the issues is when the intermix of openings and groups of trees evolved into closed canopy forest, it blocks the sun from getting to the ground. And without adequate solar heating, the native bee species can't successfully reproduce. Most of our species don't have hives like honeybees do. They make tubes either into the ground or into dead wood, and then they'll lay a series of their larvae and seal it, and then they leave. And eventually those hatch and fly out as adults. So by obscuring the sunlight and losing the understory, we're also losing bee habitat. One of the benefits of cutting openings back into the forest, as you could see here, this is signs of native bee species drilling in. Each one of these is a separate bee working on its own and then leaving a stack. Sometimes it's only 4 or 5 larvae will develop, but each one of these represents basically a mini beehive, and one that's created by our own species, not by the European honeybee, which is having its own issues. So a lot of people don't like the look of stumps, but it's also a form of habitat for some species under the right conditions, like here where it gets direct solar radiation.